Hey, 8th grade. Today in science class, we're going to go back and make sure that we've got a complete understanding of the key terms and the overall overview of what Chapter 7 was all about in terms of chemical reactions. The type of reactions that are happening, exothermic, endothermic, the release of those energies, and then the rate of those reactions and how those reactions take place with reactants, products, maybe with activation energy, inhibitors, catalysts, put all those pieces together. So we're going to start with studying, make sure we've got our vocabulary terms taken care of. I'm going to have you do the word search section that you can see here at the bottom of the page, and then we'll wrap up with making sure we've got a complete understanding in the overview of those major concepts. Let's get started. Number 1 in the column here asks us to match up the correct term in column 1 to column 2, as in our definitions here and our term is here. So let's read through. Number 1 says speeds up a reaction. Something that speeds up a reaction. I'm going to say that that's a catalyst. As we watched our video yesterday, you learned that a catalyst speeds up a reaction, and the example of that is a catalytic converter, the material that's in your car, that's in the exhaust system of your vehicle that comes out of your engine, and actually change those toxic waste products from what's burnt in your engine into something that's actually a lot less harmful in terms of the emissions that are given off. Number 2, slows down a reaction. The opposite of a catalyst is an inhibitor. So that's going to be letter F. Number 3, a reaction that releases heat. Something that gives off heat has a specific name for us. That's going to be what's called exo, because EX is that indicator for exiting. So there's exo, giving off heat. It's going to be letter B. Number 4, a reaction that absorbs heat, something that takes in that same level of energy. That's going to be endo. En is like in, being taken in, so that's G, endothermic reaction. 5 is a process that produces a chemical change. And if I go ahead and I cross out those ones that I've used, that way I know what letters I have less, I'm looking at a process that produces a chemical change. Is that a rate of reaction, product, reactant, activation energy, or chemical reaction? I'm going to say here that the best answer for us is H, the process that produces a chemical change. Chemical reaction creates something that is completely new. Number 6, a substance formed by a chemical reaction. So when the reaction takes place, what is formed? What is the new product that is created? Oops, gave the answer away. It's going to be product right there, C. 7, a substance that exists before a reaction begins. So before the reaction has taken place, you have what's called the reactant. That's going to be letter D. Number 8, how fast a reaction occurs. So you're taking a look at how fast something is used up or how fast something is produced and the time in which that takes. So it's a comparison to those two things, making it a rate of reaction. It's letter A. And 9, the minimum amount of energy needed to start any chemical reaction, like the part that gets it kick-started, is going to be what's called E, activation energy. Think about lighting a match. You've got to strike the match on the matchbox or on that match strip in order to have that actually take place. That's the activation energy, that movement and that friction that creates that. Just one example of something that needs to be started with a little bit of energy to get it going. Now, in this bottom portion here, it says circle the terms from column 2 to fill in the word search puzzle. So all of these items that were listed up here are actually in this word search. I'm going to have you do that part on your own. Flip to the other side and we've got our overview of chemical reactions. The directions tell us to use the following terms to complete the concept map below. Note that one term will be used more than once. Okay, so we want to take this concept map and make sure that it is in our brain as we follow these lines of thought or follow these sentences. We know what goes into those parts because we've got a complete understanding of what's going on. So let's start with the numeric order here. It says chemical reactions start with a what? Chemical reactions start with a, well, you need a reactant for those things to start. Now, I'm not going to cross out any of the answers because it says note that one term will be used more than once, but I'll highlight the ones that I have by writing this line down below. And a result in a product at a blank. So chemical reactions start with a reactant and result in a product at a blank. What is at a blank referring to in terms of number 5? How does this product to reactant to product process take place? It's usually at a certain rate of reaction. Depending on what reaction we're talking about, does it happen quickly? Does it happen fast? Is it exothermic? Is it endothermic? There's a rate, a speed that it's taking place. Now I know that it's rate because there's actually other factors that go into what affects that rate of reaction, which we learned way back in lesson 2. So as we follow this down, chemical reactions start with a reactant and result in a product at a rate of reaction. This rate of reaction is affected by 1, 2, 3, 4 different factors. We learned of 3 primarily, but one of those is already given to us here in this example. So we're going to look for number 6. We've got to again look at our answers up at the top. What affects the rate of reaction? I know that temperature does, so I'm going to write in temperature here. Temperature, if it's higher, usually means that there's a faster rate of reaction. If it's lower, it means it slows down, just like your refrigerator. The concentration is affecting that, because if there's more of something, there's more likelihood for those collisions to take place, therefore those bonds to be broken and then new bonds to be formed. If there's less of a concentration, then there's less of that interaction, and maybe that reaction actually takes slower or a longer period of time. Particle size is another example in terms of if there's more area or surface area for that reaction to take place, that again creates that likelihood of those collisions, bonds breaking, the new bonds being formed. And then lastly, what is the last factor that affects the rate of reaction? Something that could speed up or slow down a reaction. In this case, I think it's referring to a catalyst. A catalyst can affect that because a catalyst is meant to speed up that overall reaction. Now, let's go back. Chemical reactions start with a reactant and result in a product as a rate of reaction that is affected by temperature, concentration, particle size, and possibly a catalyst. We've got all those filled in. Now we've got 2 other branches to fill out to say what else are going on that refers to chemical reactions. Chemical reactions can be exothermic and release what? Release endothermic? No. Release temperature? Maybe. Release heat energy. Now we've used temperature once and it said that you can use them multiple times, but in this case I'm thinking it's between one of these 2 in terms of temperature or heat energy. For number 3, probably is heat energy. Think of the example that we studied earlier in lesson 2, and that was fireworks. It's a fast rate of reaction because of this huge explosion. It gives off heat, light, and sound. That heat is what that hot temperature that it's going to give us, or that heat energy. And obviously if it's measured it has a high temperature, but it's heat energy that we're referring to in that example. If a chemical reaction can be exothermic, it can probably also be the one that we haven't used yet, endothermic. And if exothermic means to release heat energy, endothermic, we know by its definition, is to absorb. Here's where we're going to use that one twice. Heat energy. An endothermic reaction, like when you break that ice pack and the contents inside that need energy in order to cool down. Well, they take the energy from the surrounding area, and that's why that ice pack feels really, really cold, because it's an endothermic reaction. It's taking it, it's absorbing heat energy and turning that into that cool ice pack that you can put on any type of sprain or bruise that you might have because of that injury. So there's another example of that. Chemical reactions can be exothermic or endothermic. They are a reactant product, and they have a rate of reaction that is influenced by these factors. If you've got that knowledge down, you've got a pretty good grasp of all of the concepts that we learned in Chapter 7. Thanks for following, and God's blessings.